Good. Let's see if it's working. Good. Let's see. Okay. Get full screen and then start. So all this while we had we introduced functions, went to limits and understood derivatives and used it to understand properties of functions. Today what we are going to do is we are going to enter the last leg of this course by introducing integrals, not necessarily definite as such, but we'll be introducing integrals and we'll be seeing some properties. We'll be seeing what does integral mean and so on. Okay, so last day we had left these two questions to be solved. So let us complete these two first. That will sort of warm up the steps of antiderivatives, and then we can go ahead and try and solve more questions. And understand what actually integrals are. So before understanding what integrals are, let's take some antiderivatives. Is the idea clear? So we'll go ahead and solve the first question. Did anybody try this question?
Yes, sir.
Okay, so this was. So what did we do? What do we need to do? So see, 1 plus x to the power 4 is the general trick to do it would be to take x square as a common factor. So why am I doing this? Because you remember d of 1 over x will be minus d over x square. So something like this I'm going to try. So what am I going to do is, see, the denominator could be easily factored also. So your numerator is x square dx, denominator is x square plus 1 by x square. So to get, I had introduced last day how to get a particular form of an integral. So how to make the d of x a function. Instead of d of x, make it df of x in some way, in case if it is possible, instead of putting some substitution methods. So that is the denominator, we can square it in two ways, right? X plus 1 over x whole square minus 2 and x minus 1 over x whole square plus 2. Agreed? Is this okay? We can square it in two ways. So you see, what is the derivative of this? The x minus 1 over x, the derivative is 1 over x square, right? And this derivative is 1 minus x square. Do you understand?
Yes, sir.
So to take this, so this is the idea. So what will I do is, the numerator I will be making it into plus x square and minus x square, because x square is the same thing. So we will try to make these as functions, d of x minus 1 by x or d of 1 plus x by x. So what we'll do is, we'll write the d as, let's still write dx and do something like this. Because we want these values in some way. That's the idea. So you see you are by x square plus 1 over x square. I forgot to write 1 minus, you are not following maybe, right? If you have any doubt, please feel free to stop me. So see, now this I can write as d of x minus 1 over x, right? And make the denominator this. Similarly, this I can write as, what can I write this as? The second part, is it not clear? So second part, what can I write it as? Also, nobody is hinting that there is a y2. So 1 over x square, I have written it as sum of 1 plus and 1 minus. So it will be 2 by x square. I have divided by 1 by 2 outside. Okay. So what will be the second integral be? Like, what will be the d of something be? No one. So this is x plus 1 by x, right? And so in the denominator I can also put a x plus 1 by x squared minus 2. Now you can integrate it, right? So this form is tan inverse x. So we had seen last day x square plus a square is 1 over a tan inverse x by a, and x square minus a square is ln of x minus a by x plus a. So half of this is root 2 square, so this will be tan inverse of x minus 1 by x by root 2 minus 1 by, so we had written 2a 2 root 2 log of x plus 1 over x minus root 2 by x plus 1 by x plus root 2 plus c. Is this understandable? Did you understand? If you
yes sir.
Yeah, great. So what I did is I tried to break this integral into two easier integrals. So to do that, the denominator and the numerator, I tried to make them the same function so that you can take the antiderivative as a generalized function. That's the general idea that I am trying to follow here. So question 2 is much simpler. What do you think we should do in question 2? So in question,
d in bracket ln sin x.
Correct. So that is, yeah. So or
yeah, directly it is ln sin x square by 2 plus c.
So sine x or log of sine x, if you see and write it as t, you get 1 over sine x into cos x, right? I'm trying to do it in a different way also, so that, right? So this becomes t and this too becomes dt, right? T dt.
Yes sir.
So this becomes t square by 2 plus c. some constant c, so t square by 2, which is also same as log of sin x by 2 plus c. Great. So these were the two warm-up questions. I thought that it's good to do some antiderivatives before we go on to understand what actually integrals are. So today the main discussion of today will be centering around what actually an integral means. So we are seeing so people have dropped out already, I don't know why, but okay. Reimann, so we'll do Riemann integrals today and limits of a sum first, and we'll see what does this signify. So let's see what Riemann integrals intuition is. So let's go down here and see what is an integral. What is the significance of an integral? So our claim is, it is the reverse of differentiation, and in order to do that, it is also, so we say that it is area under a curve, which also implies it is the reverse of differentiation. So a simple way to look at it is, you can see the fair proof also, and also a very rigorous proof that is done in the course, but the basic idea is something like this. So if you define a function f of x, right? So f of x, say x is this point, and you start from a, which is the area of the curve or area under the curve from a to x, right? So this is this area. Agreed? And if I take an infinitesimally small distance from this x, say x minus h, right? So what does f of x minus f of x minus h mean? This means that this is this area, right? So this is this area, and we write this as, so this fx, we write it as the integral of a to x fx. So this is how we are defining it, let's say, for the time being, and then we'll see why is it true. We have said it is the reverse of differentiation, so we are writing it as an integral. Agreed? So this will be a to x f of x minus integral of f of x dx a to x minus h. So a to x and x to a minus h, so you can see the area up to x minus h is same, so we can sort of leave that out and write c minus or x minus h to x, right? Agreed? Next, what we do is we divide both sides by h and set limit h tends to 0. If limit h tends to 0, you agree that these 2 points will be very close to one another, right? So your function will be a constant if it is a continuous function. Agreed? At very close infinitesimal area, infinitesimal linear space. Agreed? So your f of x and f of will be, say, tending to f of x minus h will be tending to f of x plus h. Agreed? For a continuous function.
Yes, sir.
So this is a constant at h. So you can just take it out and you will multiply it by what is this area. So we have said that this, we have our hypothesis is this is an area. So our hypothesis is an area. So the area is nothing but f of h into h, or in our case it is f of x into h, sorry, because x is the point where we are evaluating it, h is the subgap or the gap from x or the deviation from x, right?
Yes, sir.
So you see that the right hand side becomes f of xh and left hand side is f dash x, right? So you see this is the definition of the derivative, and so you have fx is equal to f prime x. So you see that the integral now, if I take a derivative of this d dx, you get the f of x, right? So clearly derivative is inverse of integrals. Agreed? So we are going to take an inverse operation. We take a derivative. If you want to take a forward operation, you take an integral to get back the original equation. So this is all I meant. So let us so that I had planned to sort of give the definition of a Riemann sum. So let's do it like a very loosely, because it's already done very well in the course. So what is a Riemann sum? What is the big thing about calculus? The best thing about calculus, I keep on saying, is you divide a problem into very, very small problems whose solution you know and put them all together, right? This is what I have been saying from the very first day. So in this definition of a Riemann sum, what I'm going to do is, if we have a curve, so you can see this what I have written here later, so I'll be doing it again so that it's easy to understand, so it can use it as a note later. So I will give you the intuition and then we can see how to use it to solve problems, since a lot of people are not there, so it's not. So see, so what we are going to do is, if we are trying to find this area, right, we will try to approximate it using rectangles. So how can you do that? In this case, you could, for example, say this is my area, right? So if you had to find the area from A to B, you could use these areas, which you know because they are rectangles, right?
Yes, sir. Length into breadth.
Correct. So the length, what did Reimann say? The Reimann said that if we could find so you agree that if you choose any point in between, so if we will write this as x0, x1, dot dot dot, xi minus 1 and xi, right? And we will have a ci between x minus 1. So this is just the formal definition of a Riemann sum. You may not always use it. We will be using a simpler version for our problem solving, but this is formal definition. So this is called a x1, x0 to xn, such that they are all greater. This is called the partition set. And C, or the centrous set, is also known as Ci, such that Ci is between xi minus 1 to xi. So you may think that it is a very difficult thing, but it is not. If you look at the diagram, these are Ci's. Agreed? Ci means we will be taking this height, f of Ci, as the height ka proxy. Okay, the proxy for height will be f of Ci, and the breadth proxy for the length will be xi minus 1, right? So your Riemann sum for a function f between, so f is sum between a and b, is defined between A and B to a real number line for a partition set P and a C set, which is the proxy for the internal sets, internal points between the partitions, is also can be written as, what can it be written as? Is the sum of all these areas, right? So it's sum from I equal to 1 to n. What is it? F of Ci xi minus xi minus 1. Agreed?
Yes, sir.
This is your Riemann sum. And if you are trying to find out the exact area, what will you do? You will make this even smaller, right? You will make the partitions even smaller so that they becomes a point, a line, sort of a very short, it becomes as short as a hair strand to be giving you a intuition for it. So if we make limit xi minus 1 tends to 0 for all I, right? So that is known as this is known as the Riemann sum. I'm putting the colors together, okay, so that you don't. So Riemann sum is this. You can define any partition and you can get a Riemann sum. Agreed? But if you want to get an integral or the area under the curve, you'll be approximating the Riemann sum by a integral. So this is defined as a to b f of x dx. And why is it done? We'll be seeing using an easier example. We'll be seeing, and this is equal to as well. Do you understand? This is a definition. We'll be seeing more intuition of it. Of this, we'll be taking a more geometric. But this is more of a high level understanding. So this is defined in the course as the norm of the partition, which is defined as max of xi minus 1 for all I. Right, so if all xi minus, if the max goes to 0, if you can replace this, your partition norm of your partition goes to 0, then all of xi minus 1 will go to 0, right?
Yes, sir.
So that's how sir has defined it. You can also define it in the way I have defined. For all pairs, it must go to 0. And that's a Riemann sum for an integral. So Riemann approximation for an integral. So you see now, how do you use it? So whenever you have limits, can you change limits to integrals? Integrals are easier to compute than compared to sum of an arbitrary series, right? We'll be seeing integrals would be easier to compute than an arbitrary series ka sum. Every series is not an AP or a GP, right? So sum of a series is difficult to compute. So for that, integrals would be a handy way to do it. So let's see. So let us formalize this. So how can you do that? So you see, if this area, so I should have told people to join today. It's very, very interesting to understand this. Otherwise, you will not understand most of integration. So I don't know why normal people also left today. Great. So you see, what I'm going to do is, for this curve, this is the partition I'll be making, and I will be taking thinking that the function is so a little bit of a problem here. Let's see. So you see, I will be taking this, and so on. I'll be approximating these areas this way. So what will I do? I can do it the other way around also. What is the other way around? This. Okay, both are valid solutions. I hope you're understanding. So
yes, sir. Left sum and right sum.
Yes, you can do either way, and you'll be getting two different solutions, which is formally again defined by a maximum and minimum. If you have the maximum So these need not be the maximum and the minimum always. So there will be a Ci for which the sum will be maximum, and there will be a Ci for which the sum will be C will be minimum, right? I'm just trying to show that right and left would give you different sums. But if you make it arbitrarily small, whatever C you choose, what is going to happen is your sum will actually, the maximum and the minimum will converge to the same value. This is the intuition I wanted to give to you. So the actual proof is very simple. You will be replacing this by the maximum of I, or which would be the mi would be greater than f of Ci, and minimum of I will be the minimum of Ci. So that's the idea. That is the minimum of between x to x and so on. We'll be doing that anyways. Let's first. So mi will define as max of f of C for C belongs to xi minus 1 to xi. And similarly, small mi will define as minimum of f of C. Similarly. So you can see your sum S will be less than small mi. This is what I meant. As you were saying, right sum and left sum, this is why I tried to say the general formulation. So by sandwich theorem, if these two are equal, your Riemann sum will exist, or your integral will exist. If these two left side function and the right side function both are same, they have to be equal for your integral to exist. Agreed?
Yes, sir.
Okay. So now you tell me, what will I'll be taking a special case, or this is also known as a limit of a sum. We'll be doing many problems related to this, because this is very important. So this is your limit of a sum. So you see, I can choose a partition like this, right? xi minus 1 is ba minus b minus a by n, right? So this is a homogeneous partition or an uniform partition, right? I partition x-axis into equal. Okay. Please, it would have been good if you had joined. You missed a lot of things. Okay. So what we are doing is, we are trying to approximate the area under this curve using sum of squares, sum of rectangles. So what we are going to do is, for every xi minus 1 and xi, we'll be taking the gap between them as b minus a by n. So we'll have n such rectangles, or let order of n rectangles, n plus 1 or n minus 1, whatever it is. So the area, you would agree, is, so your area, proxy for your area will be, what will it be? Function, if this is f of x, will be f of a plus b minus a by n into k into b minus a by n. Now I think people will have a confusion. So k will be to n minus 1. Agreed? Or 1 over n summation of k equal to 0 to n minus 1 f of a plus b minus a by n into k into b minus a. Or you can just take b minus a out. Right? This is what I meant. So what am I doing? This is your first point, right? Your x0 is a. Agreed? So if I put k here to be 0, you get f of a. So do you agree that this rectangle has an area of f of x0 into x1 minus x0? Right? If this is x1 and x1 minus x0 we have defined as b minus a by n, equal partition length. Okay, so the area of the rectangle is clear, right? Am I audible?
Yes, sir. Yes, sir.
Okay, so the x
Length into bracket.
yeah, so what is xi minus 1? What would xi minus 1 be, or xi for that matter? So x1 is a plus b minus a by n, right? So this is sort of a delta, right? This is some delta you're moving on the x-axis. x1 would be, it's an AP, your x size will become an AP. That's what I'm trying to come at. So this is x1 is becoming a plus b minus 1 into n into 1. Similarly, x2 will be a plus b minus a by n, or this is x1 plus b minus a by n. So x2 is a plus 2 into b minus a by n. Similarly, xk is a plus b minus a by n into k, right? And we'll be going all the way to xk xn minus 1. Agreed? We'll be taking n rectangles to approximate this area. Are you with me till this point? So what am I doing? I'm formulating a general equation for these xi's, for all xi. I hope this is clear. So what is the ith area of the ith square, ith rectangle? F of xi into b minus a by n. I hope this is clear. This is no other doubts. So you see, if I put n to infinity, okay, the YouTube link you can join. Am I not audible to you, everybody, to you, Mr. Pandey?
Yes, sir. Audible. No problem. Yeah.
Okay, I'll just see if it is okay on YouTube. She's saying that she's not audible at all. Okay, the YouTube link you can join. Okay, it's audible. I can hear, so it's okay. Yeah, you feel free to, but I'll not be able to see what the chats are on YouTube. That's a issue. If you could like write chats here and see the video parallelly there, it would be good. And sometimes respond through chats. It would be good. Okay. So what am I going to do is I'll put limit n tends to infinity, b minus a by n, k is equal to 0 to n minus 1, f of a plus b minus a by n into k. Did you understand that this area would become an integral now? This is an integral from a to b. F of, how will it become? Let's see. Is this okay? Is this still now okay? Till this point?
Yes, sir. Okay.
So what I did was I found out each rectangle's area to approximate the curve. So you see this, right? This you can write as, if this is your x, right? If this is your current x, this can be your dx, right? This is a very small delta which is tending to 0, right? I am trying to find an analogous for an analogous continuous thing. So this summation would turn out to be an integral, right? This is why it's known as integrals are sum of areas. So now is this entire story clear now? Why is it called, it is an area under a curve. So this becomes f of x and this becomes dx. Agreed? This is a continuous analog of a of a summation. So if you sum over areas, it becomes a integral. I hope it is clear, right? So I change this delta, this is delta, to dx at a particular point in x, right? This is the shift I'm doing at every point. Dx is a shift, right? It's a shift on x-axis. So this is your delta area. So delta area is a function of x. Right? Did you understand? And if you sum over a to b, you get the area of b minus area of a. This is also known as the fundamental theorem of calculus. So a and b can be any. So from your previous definition, this is your fundamental theorem of calculus. We'll be also seeing another version of the fundamental theorem of calculus, but we'll keep it till the end of today's session. Let us solve some questions now. I hope it is clear. So I'll understand if it is clear or not once we are solving these questions. So number 3, let us do. We are told to compute the sum of x squared dx using a Riemann sum. So what should I do? What should I do? One to 2. How should I compute it using you need to break it up into a summation, right? How do you do that? So how did you define it just now? We defined this as f of a plus b minus a by n into k, right? K is from 0 to n minus 1, 1 over n, limit n tends to infinity, right? B minus a. Here, what is b minus a here?
2 minus 1 by n.
So b minus a is 1 here. 2 minus 1. So this limit becomes limit n tends to infinity 1 over n. K is equal to 0 to n minus 1. And this becomes f of 1 plus k by n. Agreed?
Yes, sir.
This is this and this is 1. So what is f? F of x is, I have taken f of x to be x square. Agreed?
Yes, sir.
So this will become limit n tends to infinity 1 over n. So this is summation of k equal to 0 to infinity 1 plus k square by n square plus 2k by n. Agreed?
Yes, sir.
Great. Now what we'll do is we'll be taking the sum. All these sums are closed form sums, right? Summation of 0 to, so this is n minus 1. Or for our convenience, we can even write n because it doesn't matter, right? You take an extra block or a more block at the infinity. It doesn't really matter, right? If your limit n is tending to infinity, n minus 1 and n is same. Do you agree to that? N tends to infinity, n minus 1 tends to n. Whatever. So we can be a bit sloppy, that doesn't matter really. So n plus, what is summation of k square? N into n plus 1 plus 2n plus 1 by 6. You remember, right? This is summation of squares of...
Yes, sir.
Yeah. So 2 into n plus 1 by n plus 1 by 2, right? Divided by n. Agreed? Limit n tends to infinity. This becomes 1 plus, and you have n square here, so n goes here, so it becomes n cube. So this is also 1 by 6 plus this becomes, so it becomes 1. Is it? I don't think we made some mistake, I think. I don't know what. N is, n will go here, n goes, or 2. 2, sorry, very sorry. You are not saying things. So it's 2n, right? So 2n means 2, right?
Sir, 2n by 6. 2 by 6.
Yeah, it's 2 by 6. So it's n cube. So I'll divide. Okay, am I audible? I can't hear you.
Yes, sir, audible.
Yeah, good. So I'll be breaking this up. So this will be it's 2 into 1 into 1, 2 by 6. So it's 1 by 3, 2 plus 1 by 3, which is 7 by 3, which is matching, right? X square ka integral is x cube by 3. You put 1, you put 2, it's 8 by 3 minus 1 by 3, which is 7 by 3, right? Matched? So we really see that if you take sums also, you can do integrals. Integral is nothing but a clever sum, right? Clever sum of areas. So we have what did we learn till now? An integral is a sum is an area under a curve. Number 2, area under your inverse of an integral is a differentiation. We have learned about Riemann integrals. We have learned about Riemann sums. Next, this is your assignment question. So what does it say? You need to solve. So let's do it in a small little place here. It will be not taking a lot of space. Or maybe should I copy it? It's not fair. People seeing on YouTube may not be able to understand. Okay. This is your question 4. So question 4 says that how do you find this area, right? How do you find this sum? So any ideas? See, this is from your definition of your Riemann sum, right? Can you see your definition of your Riemann sum that we defined before? F of Ci xk or xi minus xi minus 1 for I is equal to 1 to n, limit p tends to 0 is nothing but integral of f of x from a to b. This is for a to b, right? Dx. Agreed?
Yes, sir.
So your f of x here is 1 over 2x minus 1. That's it. That solves your problem. 1 to 5. Right?
Yes, sir.
So this is the way you should do your problems related to this. So I'm going to do that our trick that we have been discussing 2 days now. Then I'll make d of x d of 2x minus 1. So that becomes d 2 dx. So 2 I will divide outside. Agreed? This step is, I'm not taking any substitution in this. I hope this is clear. So 2x minus 1 to the power half by half 1 to 5. Agreed?
Yes, sir.
2x minus 1 to the power half integral is 2x minus half integral, and with dx, with d of 2x minus 1, so you can take this as t, so you will get t to the power of half by half. That's what I've written. So this will cancel, so you'll be left with 9 to the power half minus 0 or minus 1, right? 1 is 2, 2 minus 1 is 1, 1 to the power half. Agreed?
Yes, sir.
So
3 minus 1 equal to 2.
Yes. So we have seen a couple of things. So first thing we have seen is this sum, limit of a sum is equivalent to integral. both sides. Then we have also seen, which is also equivalent to area under the curve fx. We have also seen limit. We have seen integral of a to b fx. We have seen the rough intuition for it. We'll be seeing through fundamental theorem of calculus more formally. Okay, f of b minus f of a. We have seen this via the assumption that it is an area, which is true. We have seen this in this form. We have seen this, right? D of a of x, a of b minus a of a. This is what we have seen. A of b is the area till b and a of a is the area till a. So these things we have seen, where f dash x is f of x. Right? Now let's solve a few more problems. So we have been able to do these two questions. This is 2. Now I have defined limit of a sum before only. So this is the one. This is also equal to f of b minus f of a if f dash x is equal to f a. We have seen all these steps. Now is the real fun, or the problems that we are going to solve using integration. But the problems, why I was saying integrals are easier to compute than sums, is because something like this. You see, this may be an easy sum first, sum may be an easy sum to compute. You may take 1 by n and take a limit and 2n into n plus 1 by 2 and solve it, right? But we will not be doing that way. We will be trying and solving it using integrals, right? Just to warm up. So you see, limit n tends to infinity summation of k by n square can also be written as 1 over n summation of k equal to 0 to infinity, or n for our matter, limit is n is tends to infinity, or this is 1 to infinity for our case. So 1 to infinity, 1 to n, 0 to n minus 1, 0 to n, 0, everything is same. Just remember that, because it's just 1 point infinitesimally, so it doesn't matter to a sum. So what is it? K by n. Agreed? Agreed?
Yes, sir.
So k by n, what can I do? I can write this as 0 plus k by n, right? This is how we will define this for functions, right? So how will you define this as a function? This k by n can be written as x, right? Or for making matters very simple, so we will compare this with b minus a summation of k equal to 1 to n f of a plus b minus a by n into k, right? Agreed? We'll be doing this. Okay?
Okay, sir.
I think you're not understanding. So see here, b by a is your 1. Just compare these two functions. And a is 0, right? A is 0, b is equal to 1. Agreed? If you compare these
Yes,
two,
sir.
correct. Now you see k by n, what you have? So you have k by n. So f of k by n is equal to k by n. This is the comparison now. So this has turned into k by n, and this has turned into f of k by n, right? So f of k by n is equal to k by n, right? So what does it mean? f of x is equal to x, right? Yes or no?
Yes, sir.
F of k by n is k by n, so it's a constant function, it's a linear function, right? It's equal to,
Yes,
it's the same as the argument. So I will choose f of x is x. So if I choose that, what do you see? So this turns out to be, what integral will it turn out to be?
X dx 0 1.
Correct. Or this area is half. Right? So next problem I will not totally do. You will tell me the function that I need to choose. Let's copy all these questions now. These are all similar questions. One was your assignment question as well. Okay, let's solve. Question 5. 5 is done, so we'll erase this 5. Let's do number 6. So what is the solution that we'll be using, incorporating? Any idea? L. Just give me the start, rest I'll try and do. What do you think we should start with? So this sum is not easy to compute, do you agree?
Yes, sir. Complicated a bit.
The previous sum was just AP, easy to compute. This sum is not easy to compute. So we need hopefully a use of integrals, right? So how do you do this?
Yes, sir.
Yeah. So what step do you follow first? So we will always try to formulate an equation of the form f of r by n or k by n. This is the try f of k by n. Why are you trying to f of k by n? Because this is your delta, right? This is your value of x. Try to make your equation f of b minus a k by n for 0 between 0 and 1, right? Between 0 and 1, if it is, then it is k by n. So if you try to make it between a function like this, then you can replace it by an integral, right? We have already seen this summation b minus a by n is the integral of a to b f of x dx, right? Let's see, I think we'll be solving, it will become more simple. See. So what will we try? We will try to take 1 by n outside. So what is the first step? Try to take 1 by n outside. I took 1 by n outside, right? Next, summation of 1 by 2 plus 2 plus 2 plus k by n, right? K equal to 1 to, or in our case k is from 0, because this is 2 half to n. Agreed? Is this matching or rather 3n in our case?
Yes, sir. fx is equal to 1 by 2 plus x now.
Correct. But did you understand why it's between 0 and 3n? This is 5n, right? So this is 2n plus 3n. You need to go 3n out, right? Or if you take 2n common, you need to go 2 plus 3, right? So you're just not going to go 1 times but 3 times. Just put k equal to 3n, you will understand. 3n by n plus 2. This is equal to 5, right? Agreed?
Yes, sir.
So you need denominator to be 5. That's what we are trying. Agreed? And then you can multiply n outside, you will get 5n. So starting from 2, it's going to 5. Agreed? Now tell me what will be this integral. So what will I take f of x to be first? Let us again compare. F of a plus b minus a by n into k. Sum of k equal to 0 to say sum n for the time being 1 by n, say alpha n. Why am I putting alpha?
A is equals to 2 and B is equals to 3.
Are you sure? A is equal to 2, right? And B is
3.
B is equal to 3. You see the outside has become 1, right?
Yes, sir.
Now this also has become k by n. So it's an integral from 2 to, say a is 2 and b is equal to 3. So this will be turning out to be, so are we all correct? B minus a 2 plus, yeah, correct. So previous, so your sum integral, what is f of x now? F of x can be written as 1 by 2 plus x, right? One by 2 plus x. Are you with me?
Yes, sir.
So if you have f of x is equal to 1 by 2 plus x, then you can write this integral between, I don't know, let me make a mistake. No, it's not a mistake. But why is it 3n? Okay. So it is between 1 by 2 plus x dx 0 to, or rather we are going to integrate it from 2 to 3, right? Why are we integrating it?
Yes, sir.
From 2 to 3? Oh, now I understand. F is equal to 2, it has to be f of x. We are doing it wrong. See, f of 2 plus b minus a by n k has to be 1 by 2 plus k by n, right? B is 2, we have put k by n. So what is f of x? 1 over x, right? Not 2 plus 1 by x. Your whatever is in the argument, if you take as t, your this is also t, right? Do you agree?
Yes, sir.
So this is 1 over x, not 1 by 2 plus x. If you had taken 1 by 2 plus x, that is also a valid thing that she is telling, but you would have to define the function differently. You would have to take 2n plus k and do something to make it a function of 2 plus x. So let's see. Now for the time being, if this is true, your t will range between, your f of x will range between 2 and, where is it? X will range between 2 and 5. Is it? We'll just see once. Let us see. Let us just write down definition once. F by 1 by n summation k is equal to 0 to n f of a plus b minus a by k or n into k is the integral of a to b f of x dx. This is for a to b, but is it b? So we do not want, yeah, it's happening, translation is happening, so we'll need to do that. That's what I'm thinking. So k is, this is your numerator, so it is 3n for our case. So I just think I have,
Sir, directly we can do lower limit equal to 0, upper limit is equal to 1, and function is equal to 1 by x plus 2.
no, that though you can do 1 plus upper limit, not x plus 1, because you will be having up to 5, right? So this is, I'm trying to make this in this form so that we are not going to do it between 0 and 1. So this is between 3 minus 2 by n into k. So if I divide by 3 and multiply by 3, or rather this should go to, actually k should go to 3n. So 3 times this should show your denominator or your numerator should be larger. So now I understand. Let's see. So if it is, this is the integral between these two, if this is the case, so you see b minus a and k is equal to 3n, right, by n is equal to 3, right? So that is the first point. This is the first, and b minus k is equal to 0 would be, k is equal to 0, b minus a into k by n would be this. Agreed? Would be 0. So our integral will if we take our entire function 2 by 2 plus x to be this thing, so we will have the integral ranging between 0 to 3, right, instead of 0 to 1. 0 to 3, and your denominator, your function is this is your function. We were actually right, I think. Ln of 3 by 2. Or we could have, what you said is also correct. You could have taken f of 2 plus k by n, right? And we found that this was equal to 2 plus k by n. And you are saying you take it as 2 plus x, right? That's what you are saying. I can also write this as f of k by n equal to this. Do you agree? Let's do it properly. What he is saying is correct. This a and b problems, we leave it. Yes, I understood. Yeah.
Sir, in both cases we are getting same values.
Yeah, you will get same values only. But I'm just trying to make it simpler. And since there was a confusion, let's do it once again properly. So I'll be taking this function, right, f of as x, and so your f of ki, xith term is, so how do I write tk, term tk is 1 by 2 plus k by n, right? So we said we will replace r by n by x. So we'll do something like this. So f of x, right? Or let us write f of k by n as 1 by 2 plus k by n. Agreed? Or we can write f of x as 1 by 2 plus x. Now there is no problem. Now your k can go to any limits. This is something like this. So your sum will become Now you can write this as f of 0 plus b minus 1 b minus a into n into k. Agreed? And your value of k will range between 0 and 3n. So or you can not even write 3n, so you can make it just n and put 3 here, right? So since a is 0, right? And you can put divide by sorry, what am I making a mistake here? B minus a, b is still 1, right? So it is 3n, 1 by n. Yeah, b is still 1, a is equal to 0, and you are taking the sum to 3n. So your if it was up to n, you would have gone to 1. If it is up to 3n, you would go to 3, right? Agreed?
Yes, sir.
Just put k equal to 3n, you will get it. So b k by n into 3n is equal to 3. So this, what will this integral turn out to be? 0 to 3 ln of or dx by 2 plus x, right? We have taken fx to be 2 plus x. Agreed? Or,
Yes, sir.
so this is equal to ln of 5 minus ln of 2. This is equal to ln 5 by 2. I think this is correct. This is matching. So what we did is, since we are taking an integral up to 3 times the initial integral, we are just replacing the initial 1 by 3, right? So because initially our limits, so remember how we did it, a to b, right? So a to b is here n, 1 by n. A to b we have divided in such a way, 0 to 1 is this. So your 0 plus 1 by n into k, if I put a sum till n, this is between a to a plus 1. If the sum is between a plus 1 by n, k is equal to sum alpha n. Your sum will range from a to a plus alpha, right? A plus alpha. Agreed? Right? At 0 it is a, at n equal to k alpha n, this is equal to a plus alpha. I hope this is clear now, right? This is ln of 5 by 2. So next question. So is it okay? Or do you have a specific doubt you can ask? So
No, sir, clear.
any other person, other? Mr. Pandey?
Clear, sir.
Yeah, just scale the integral. That's what I was trying to do. This one, limit n tends to infinity 1 by 4n square minus r square. What will it be? How will I solve? Say r is equal to 1 to n. So what would be the steps for this? You take n common to have a summation like this, right? We have already seen a summation like this, 1 by n f of a plus k by n. So if I
Under root 4 minus r by n whole square.
correct, and you will have a summation of r is equal to 1 to n
1 to n.
and
1
1
by
by
n.
n. This is one line, there's nothing to think, you need not even have to plot. So this is your, now your f of x, you can write this as, or f of r by n, you can write it as 1 by root over of 4 minus r by n square, right? Or your f of x can be written as 1 by 4 minus x square, right?
Yes, sir.
What is b here? So we'll compare it with this equation, f of a plus b minus a by n into k, 1 by n. So your b is equal to 1 and a is equal to 0, right? Agreed?
Yes, sir.
Correct. So you see b is equal to 1 and equal to 0. This is also b minus a. So this is correct. I is equal to 1 to n. Similarly, this integral will turn out to be, what will it be? Dx by 4 square minus x square from 0 to 1, right? Or this is also known as sine inverse x by 2 . So let's see the inverse just once. We can also take the antiderivative and see. So x a square minus x square is just sine inverse x by a, not 1 over a. Right? So this is equal to sine inverse half minus sine inverse, what is it? 0. What is sine inverse 0? We have seen it in the first few classes.
0.
So this is your sine inverse function, right? 1 is pi by 2 and minus 1 is minus pi by 2. What is half? Pi by 6. 30 degree, right?
Yes, sir.
Half is 30 degree. 30 degree sine 30 is half. This is half is pi by 6. Okay. So this is what we were trying to do. Now the last one. This is also your assignment question. So what does it say? Limit n tends to infinity sine k pi by n summation of sine k pi by n for n is equal to 1 to infinity and to 1 over n, of course. Question number 8. Right. So what will I do with this? So any idea? What should be the function? How should I write it? So let's write it in the general form, right? N into n tends to infinity 1 by n summation of k is equal to 1 to, this should be n, not infinity, because we're already taking the limit, and then 0 plus k pi by n. Agreed?
Yes, sir.
So what is your so you see k is here, or you even have something like this, pi multiplied by 0 plus k by n. Agreed? This is even better.
Yes, sir.
This is even better. Why am I doing this? To avoid scaling. See why am I doing this? So if I take f of x as sine pi x, right? So I will have a plus b minus a by n into x as sine of pi into a plus b minus a by n into k, right? And here I will take b as 1 and a as 0. Agreed? If I do that, I get pi of I know you are. This is easy to understand. So 1 by k or 1 by n into k, which is your original function, right? So this is your a, b is equal to 1, and your limits of integral are between 0 and 1, right?
0 to 1.
So this becomes an integral of sine of, I'll just touch upon that point. I was a bit confused. I'll be touching upon what I was thinking, and then we'll be going to the next part of the last part of today's session, dx, right? This is also known as, what is this equation? What am I writing? 0 to 1. What is this equation? What is the integral? So I'll make the trick, pi x and divide by pi. Are you getting familiar?
Minus cos pi x divided by pi.
Yeah. So are you getting familiar with what I'm doing with the d of something? I'm just taking d, trying to match the function that the function is of. Scale it or make it a function, sum it, right? If you are not understanding d of something, so you can take pi x is equal to t and do it, but still I would prefer you understand what I'm doing. I made this d pi because d pi x is equal to pi dx, right? And so you can put this side, so you can have 1 by d pi x is equal to dx, and replace dx like that. So why am I making it d pi? Because your function is of pi x. Agreed? Easy to compute, that's why. Between 0 and 1. Or this is equal to 1 by pi minus at 1. So what am I doing? We will also see this thing later. So let's do it by using fundamental theorem of calculus only. We'll be putting cos pi minus cos 0. So what is this? Cos pi is minus 1, 0 is 1, right? Agreed? So it's 2 by pi. Okay? Is the steps clear? So this is your cos, this is that x is equal to 1, this is that x is equal to 0. I hope you understand this question as well. So I'll just what I'll do is, I already told you how to sort of solve a particular convert it into an integral. We'll just do it for a different case, maybe in case of, see, you could also what should we do? One thing we could do is we can finish off what we've thought, and then we can come back to this and figure it out offline. That would be better, I think. Yeah. So let's go to the next part. I think this is clear. So we have done all these questions. Now we'll try and do areas. Few areas, will be going into areas and volumes more in the subsequent weeks, next 3 weeks. But today I will give you, so till now we have seen that area under the curve was given by an integral, right? This area was, this is what we found using the Reimann integral, right? So what I'm going to say is, so if you are told to find area of an arbitrary surface, integration is the way to go. So you see, your areas would be positive above the x-axis and negative below the x-axis. Are you understanding why will it be so? Because your fx is less than 0, right? If fx is less than 0, then your integral is less than 0, right? You can always put, this is always less than 0, so you can always put 0 to that function and make it a constant function, right? You understood the proof. Why is a curve below the x-axis having a negative area? Is it clear?
Yes, sir.
So your f of x is less than 0, so I put it upper bound to that function as 0, and which turns out to be less than 0, right? So your f of this will be less than 0. So to make just to find the magnitude of area, what will you do? What will you do? I had said this in the first class, right? So if you want to invert your area, you will be, what will you do? If mod of fx, right? If you take mod of fx, you take a reflection over the x-axis, everything inverts, right? Hope it is clear. And if you want to take a non-signed area, you will be taking an integral. Sometimes it may be useful, right? Something is below the ground and so on. I hope it's very clear. So let's solve the questions first. Let's solve the easy one first. Question 9. So what is y is equal to x square? How does it look? And x is equal to y square. How will it look? Tell me. So this is also equal to y is equal to root
y is
x.
equals to x square x upward parabola.
This is one function, this is one function, right? We have already seen, because this is an inverse function. Inverse functions are reflection over y equal to x line, right?
Yes.
First few classes we saw how to find inverses. So y is equal to x square. If you do x is equal to root y, and you will take f inverse x was equal to root x, right? We had done this as the inverse function. If you take a square root of a square, it's an inverse. That's what I meant. So you see it is at 1, both are 1, and your root x is defined only at, so this is a parabola, rightward opening parabola, right? Y square. So this is something like this. So you will have no intersection below the x-axis, agreed?
Yes, sir.
And this is this is the area that you are told to find.
Yes, sir.
Which is above and which is below?
Y is equals
This is,
y is equals to x square below.
yes. So what can you write? You can find this area as difference of areas, right? You can either find both areas and subtract it, or write it as a single integral. Sometimes writing it as a single integral may help. That's why I'm trying to help you out with that, right? There are a few ways you can do it. Do you want me to show all the ways? Exercise. Let's do it, right? And I'll show you 3 ways, and I think it will be useful. So first let us solve the easiest way. So easiest way will be the integral of area 1 would be, just do it in one line, right? X squared dx from 0 to 1, right? It's 1 by 3, agreed? A2 is 0 to 1 root x dx, which is nothing but equal to x to the power 3 by 2 by 3 by 2 is equal to 2 by 3, agreed?
Yes, sir.
So your area shaded is 2 by 3 minus 1 by 3, which is 1 by 3, right?
Yes, sir.
So since we have a time today, little bit of time today, I'll just try to show you how to, this is very useful because you'll be doing volumes and all, there it will be more useful. Let's see, with using different ways, how can you solve the same question. It may be that y equal to x, expressing y in terms of x may not be useful always. Sometimes expressing x in terms of y may be useful to find areas. Understood? So that's why I'm trying to show you what to do if that is the case. Like the next question only will be sort of that way, maybe, I don't know. See, so this is one and this is another. This is your y is equal to x square and this is your y is equal to root x. So you can do 2 things, right? You can do integral y dx, right? This is your y, this is your dx, and you find this area, right? This is your y dx, or f of x dx for our what we have been doing. This is one way. and that also can be done as x dy, right? What does it mean? See, for this x you can go dy upwards and still find this area, right? Agreed?
Yes, sir.
So these two ways we can do. So way 1 I'll show now, and then when way 2 also I'll show. First I'll do way 1, or the integral y dx, or the normal figure that we always try. So y dx would be like this. Okay, so now if I want to find this area, what should I do? This partial area. I'm also trying to solve this part as well. I'm trying to show you that it is important to write a single integral to find any area instead of writing two integrals. Sometimes it's very useful. So you see, what can you write this as? You can write this as a d area 2 and d area 1, right? Like this you can write. This will give you your entire area. Agreed? We are integrating small areas to get the complete area. So what will be what is dA1? So your dA1 is x of, so y is, what is the value of x? f1x minus f2x dx. Do you agree this is the same thing? Instead of writing 2 dx, I am writing a common dx. Agreed? f1x is greater than f2x. Are you understanding what I'm meaning? dA can be written as f1 into a dx, right? Your differential area is the function value into the small x interval, right? Somebody, am I audible or is it not understandable? Hello?
Yes, sir. Understandable.
No,
But
yeah.
do it by calculating the value of y dx area. Y is equal to y1 is equal to f1x and y2 is equal to f2x. Y1 minus y2 is equal to f1x minus f2x. That is the length.
No.
Of the strip.
Yeah, that you can think of that way, but what?
Yes, sir.
I am trying to, so that is also correct, but you are trying to find the derivative. I'm saying dA1 first area minus the second area. So the other way around is a bit difficult because both sides you are approximating. So let's not approximate both sides, right? So it's okay. I'll give you the same answer, but for intuition, see, dA1 is your the upper area. This is this area. So this is the first curve passed here, second curve passed here. What you said is absolutely correct. So you will take the entire area first and subtract this area, right? So if you have two curves, you can make a new curve as f1 minus f2. Did you understand what is the proof of this? So sometimes what can happen is you don't need to calculate f1 and f2 separately. Some terms will cancel out if you can do this. Agreed? I hope it is clear. So this would be x, f1 is your root x minus x square, 0 to 1. This is also 1 by 3, same equation, right? Another way is way 2. Sometimes it's very difficult to find y as a function of x. It is easier to find x as a function of y. So this is your y is equal to x square or x is equal to root y, and this is your x square, y is equal to x square or x square is equal to y. What am I writing? X is equal to y square, right? Agreed?
Yes, sir.
So we will still integrate up to 1. So can you tell me which function is now right? This is your to the right. So we'll be subtracting these two area. It's a horizontal strip as he is telling. So I'll be using the horizontal strip. So your function to the right is this function.
Y square minus root y.
Yeah. So where is this? So your right function is still root y, right? So it's not y square minus root y. So right function is this one, right? This is root y equal to x. Agreed? And this is
yes, sir.
and this is x is equal to y square. Agreed?
Yes.
I'm just writing x as a function of y and y as a function of x. In the second case, I'm writing x as a function of y. Right?
Yes, sir.
So dx and this is dy. So this will be root y minus y dy. Since this is a symmetric function, you're getting the same answer. It will not be the case if you have an unsymmetric function. We'll do it in more such questions next time. Maybe we'll be able to understand. So you can either take areas with respect to the y-axis or the x-axis and subtract off non-important areas. This is also done. So number 10. This is an important, nice question. This will give you some idea. Just let us breeze over this. This is not a tough question, but just we need to see which function is above and which is below. So how will this look? So what is x square plus y square equal to 1?
Equation of circle.
With radius 1.
Center, with radius 1, center 0, 0.
Correct. I think it is a circle. I don't know if maybe it's like becoming like an earth. What is happening? Okay, so this is a circle, x square plus y square equal to 1. What is for y greater than 0? Y is equal to 1 minus x square. It's an upper. Do you agree that it is an upward opening parabola? Something like this. We'll see why it is below and why it is not above. Do you agree? This is your 1 minus x square. Y equal to 1 minus x square. Right?
Yes, sir.
So what is mod y is equal to 1 minus x square? I had told. So if we take mod on the function side, what will happen? On the dependent variable. So these will also be true for all the values below symmetrically below the x-axis. Right? So for example, 2 is equal to 1 minus x square. If y is equal to 2 and is y is equal to 1 minus x square, then y is equal to minus 2 is also 1 minus x square, right?
Yes, sir.
So this is actually wrong, but 2 will never come. 0.5 let's write, right? So you will have a symmetric curve both sides. So here comes the symmetricity of integral. So what is the things you should do? You should find only one area like this and multiply by 4, right? Agreed?
Yes, sir.
So your what is this area, right? As a one integral, this can be written as y is equal to root over of 1 minus x square, right? The first equation. I hope it is. So So it's this. Y is equal to this. And what do you subtract it from?
1 minus x.
Correct? From between 0 and 1. Agreed? X is between 0 and 1, right? We have just taken x into x greater than 0, y greater than 0. This into 4. Agreed? The second integral is very easy. Second integral is 1 minus 1 over 3, right? Right? Or not? 1 minus x square dx is equal to x minus x cube by 3 at 0 and 1. So it's 2 by 3. Correct. So the first integral, do you know what to do? 0 to 1, what formula is this of? Have I written it down? I hope I have. I haven't. So we don't even need it. Can you tell me why do we not need this integral? I can write this integral in one line. I will show you this formula next class, but we don't even need this formula. This formula is log x plus 1 by x. Why do we not need this?
Because it is a area of the circle
by 4.
In by 4.
Right, I was just seeing if you could. It's not even required. Log of 1 minus x square is sine inverse x by a plus x root over of a square minus x square plus c. This is your formula for your answer. So this goes to 0. This is matching, right? So if you put pi by 4, 1 by a, I think will be there, 1 by 2a, something like this as far as I remember. So this becomes sine inverse pi of pi by 2, something like this. I'll just have a look and put it because it's not a worth thing to do now. So you see, so this is pi by 4, right? So area of a circle. Agreed? This is an area of a circle. So the area is pi by 4 minus 2 by 3. So just see if it is greater than 0 and then we can think that whether our assumption is first of all correct. I'll just see if it is pi by 4 shift pi divided by 4 minus 2 by 3. This is 0.11. Is this the answer? The answer is 4 into this. Is 1 by 4. Agreed? Okay. So you could try this. I had seen this using a see, I am not convinced that this is below the curve. Can you tell me how to get convinced that that it will be below the curve? So what you'll do is, go ahead.
By calculating the value of area, if it is positive,
no.
First answer is
no. It can be like this also, na? We know it's not like this, but it can still be positive. So you can do something like this. So 1 minus y square, right? 1 minus whatever you have. 1 minus x square minus 1 minus x square as some f of x. And at x is equal to 0, this is equal to 0, right? Agreed or not? Okay.
yes, sir.
Yes, sir.
Then take f dash x and see where it is greater than 0. You will see it is increasing up to this point and then decreasing. Also, you will from 1 onwards you will see this is increasing this way. So here, so you will be seeing it's always above the curve. Did you understand the solution? I'm not just going to this because we have already done this 4 times for this type of questions. Did you understand what I'm saying? So I'm saying something like this is equal to f dash x is 2x by or x by 1 minus x square, right? Minus x by 1 minus x square plus of 2x is equal to 0. So x is not equal to 0 if you put, so you will have 1 minus x squared is equal to 2. Just do this calculation. What is it? Half 1 minus root over 1 minus x square is equal to 2, right? 1 minus x square is equal to 4. 1 minus x square is equal to 1 by 4. X square is equal to root 3 by 2. Right? X is equal to root 3 by 2 tak it's going to increase and then it's going to decrease. If I have done it correctly, yes, it is also correct, root 3 by 2. Understood? This is greater than 0, increase till x belongs to root 3 by 2 and then decreases to 0. Agreed? So do you see that it is always above the curve? Did you understand? So if it is increasing means what? Your 1 minus this function is greater than this function for root this value, and if you see the decreasing function, that is also increase. The complete proof will be at x is equal to 1 and you go backwards and you still see an increasing function. X at x is equal to 1 is also 0, right? I hope this is clear, right? Just ask me if you have a doubt, otherwise I cannot proceed. And we saw that functions were monotonic by using derivatives, right? If it was derivative, it was always growing. So here the function is increasing up to 3 by 2 and then decreasing, and it's decreasing to the same value. So I'm saying that it's always above this original function. Is my
Yes, sir, right. Got it.
So this was an interesting question. The last thing that we'll do today is fundamental theorem of calculus. We have already done. I have written this proof down. This is the same proof that I showed in the beginning of the class, right?
Yes, sir.
So I hope you remember, Mr. Pandey. You said yes that time.
Yes, sir.
So what I will do is I will be using fundamental theorem of calculus to prove a more general theorem, which is also known as the Newton-Lebnitz theorem. This is a question that I have given. Can you tell me how can I prove that derivative of an integral is given by this value? So what is the proof of number 11? This is a very, very fundamental theorem. You can directly use it. So it's you're putting the value inside the function and you're multiplying it with a function's derivative. Doesn't it sound very familiar? It's like the chain rule, right? It's chain rule plus fundamental theorem of calculus put together. Can anyone tell me how to prove this? Or I'll start. I'll give you 1 minute to think, because this is the last important thing to this session.
Carpet rolling and unrolling concept.
No, I don't know any such. So you're saying, what is that? What will I do? So I was thinking I would write f of x as integral of fx, ft dt. Right? With some c constant, as we have seen before. If I write this, So can you tell me what will your integral look like? So your integral from phi1x to phi2 of x ft dt will be, by fundamental theorem of calculus, is agreed? Because your variables are t, doesn't depend on x, right?
Yes, sir. Now differentiate it.
Yes, so simple proof. We don't need anything. You need to define f properly. If you differentiate, you get f dash, exactly the chain rule. I gave you the hint, right? You have to use chain rule and fundamental theorem of calculus. Right? This is nothing but fx, right? So f dash x is fx, as we have seen before. So it's f dash of phi 2 of x, phi 2 dash x. Now when you'll be solving question, you will only tell me how useful this is. This is such a powerful result that you can use it everywhere. Right? Proved?
Yes, sir. Yes.
Now let's prove number 12. Let's see what is in store in number 12. So you see pi by 4, right? What is sec square pi? Sec pi by 4? 1 by cos pi by 4 is equal to 1 by root 2 is equal to root 2, right? So sec square pi by 2 is 2. Agreed?
Yes, sir.
So do you see that it is a 0 by 0 form? Because your numerator is integral from 2 to 2 ft dt and 2 to some delta. This is 0, tends to 0, right?
Yes, sir.
And denominator is also pi by 16 minus pi by 16. This is also tends to 0, right? Now what can we use? See, Newton-Lebnitz or the fundamental theorem of calculus accompanied with the L'Hopital's rule, right? 0 by 0 form, we can directly write this as limit x tends to pi by 4 ddx of integral of 0 to 2 f t dt, what 0? 2 to sec square x by x square minus pi square by 16. So tell me, what is the numerator differentiation of the numerator?
Sir, numerator is f sec square x into 2 sec x tan x, and denominator is 2x.
Are you right? Sec x derivative is sec x tan x, right? So we will have a sec square x.
Yes, sir, sec square x.
So first you will be differentiating ddx of 2 sec x into ddx of sec x. So you will have 2 sec x tan x, so it's sec square x, right? Minus 0. 0 why?
Yes, mine.
This is a
Because
constant.
differentiation of 2 is
0. So anytime you have a constant, you can just leave it out. This is the another use of Newton-Lebnitz. So now you put limit pi by 4, you see. What do you see? Now all the points are non-zero by 0, all are real values. Agreed? F of 2 into 2 into 2 into tan pi by 4 is 1 by 2 into pi by 4, right? This we said is 1. So this is 8 by pi. Was the Newton-Lebnitz theorem useful? I hope it is. You can use it everywhere. So the last 2 questions that I ever thought of were very simple questions, but it will give you an idea of the definite integral questions that are not relevant not so much covered in this course, but I'll anyways cover these properties, but I think you know it all. So minus t to t if a function is even, right? So even function is like cos x. So you can we have already used this in the area calculation. Do you remember? So you found one area of the square and multiplied by 4, right? Using symmetry. So see, since this is area calculation, so if your function is even like this, so 0 to t, so if your function ft is equal to f of minus t, it is equivalent to calculating the area of just the positive part and multiplying by 2. Agreed? And similarly, if you have equal on both sides, this will cancel. This is a positive area, this is same negative area. A minus a is equal to 0. Agreed?
Yes, sir.
This is for period. This is for odd even functions. The second thing we'll be using is a to b fx dx is equal to a plus b minus x dx. So I'll show you why this is true. I have the proof there, but I'll do it again for you to understand. See, I don't want to write it. So you see, if I'm taking a to be 0, I can always do that, right? Without loss of generality, because I can always recenter a curve at 0. We have already seen that. Agreed? We have done that previously. Do you remember? So x a to b can be written as x minus a. We can integrate x minus a as an integral, right? X minus a is 0 centered, right? So if we do for one side, we will be done with both sides. Agreed? Okay. So this is your f of x. What is your f of, so in our case, what is f of x minus b? Can you tell me? What will the function range from to range to? X minus b. We have done this extensively first 4 weeks. X minus b is centering at b, right?
Yes, sir. Shifting right side.
That's
B
what
units.
So you are just centering at b. That's what I've said, right? Now this is your new axis. This is what we had defined. We had seen in plotting curves. Now, what is f of minus x minus b? It will be a reflection over your y-axis, right? See. Agreed?
Yes, sir.
So this is your f of b minus x. So what is it giving you? See, at b by 2, your functions will be equal, right? Agreed or not?
Yes, sir.
So whatever area you have this side is present in this side, and whatever area you have this side is present this side. Agreed?
Yes.
So your integral of fx dx 0 to b is same as b minus x dx 0 to b. Do you agree? Because your areas are still the same.
Yes, sir. Understood.
Great. So let's solve the last 2 questions. Number 13. What is number 13? What will I do? Tell me. What property should I use?
a plus b minus x
Correct.
property.
So this will become minus sine x, right? A
Yes, sir.
plus b is equal to 0 here. And that is equal to, now this is your I. This is also your I. So if I sum I plus I will get 1 plus e to the power sine x by 1 plus e to the power sine x dx between minus pi by 2 to pi by 2. This is 1. So dx from minus pi by 2 to pi by 2. So it's a constant function. What is it? Pi. Agreed?
Yes, sir. And divide by 2.
This is 2i. Thank you. Now I am seeing you paying attention. 2i is equal to pi. I is equal to pi by 2. Understood?
Yes, sir.
So let's solve the last question for today, and then we can stop and maybe stop the recording and all, and then we'll see whatever we were confused with. This is also an interesting question. This I won't do. I will sort of let you think for a couple of 1 minute. Question 14. Straight away I won't do it. What should we start off with? Give me one step and then we may proceed in this direction. If we do not succeed, we'll come back.
ln sine pi by 2 minus x.
Okay. So you are saying this is I.
Yes,
I
sir.
is also equal to log of or ln of sine of pi by 2 minus x or cos x. I'm just
Yes,
writing
cos
cos
x.
x directly.
Yes, sir.
Now, like the method we used last equation, I'll also use this 0 to pi by 2 log of sine x cos x dx. Next, do you have any idea? This is as bad as the previous one. How to make it better?
Sine 2x by 2.
Good. So I'll multiply 2 and divide by 2. So this becomes sine of 2x by 2. So I can write log of sine 2x dx 0 to pi by 2 minus log 2 integral of 0 to pi by 2 dx, right? Agreed?
Yes, sir.
Log of sine 2x by 2 is equal to log of sine 2x minus log 2. This is what I used. So now comes the substitution, the trick. Or if you could see scaling in your eyes, you don't even need to use the trick. So you see 2x. When I do 2x for pi by 0 to pi by 2, it becomes between 0 and pi, right? You can easily see it by how? Say 2x I will take as t, right? Agreed?
Yes, sir.
So see, x is equal to, I make a chart like this. When x is equal to 0, your t is equal to 0. When x is equal to pi by 2, your t is equal to pi, right?
Yes, sir.
Now dx is dt by 2. Agreed?
Yes, sir.
So I will replace this equation as 0 to t equal to 0 to pi. This is what I wanted to show you, how to do substitution for definite integrals. Did you understand how to do substitution for definite integrals?
Yes, sir.
So I replaced x to t. So log of sine t dt
dt.
by 2, right? This is equal to 2i. Is it? Yeah.
Yes, sir.
Now you see integral of 0 to pi log of sine t dt. Do you see it's an even function about pi by 2? Sine t. Do you agree?
Yes, sir.
So if I find this area and multiply by 2, agreed? You will be happy?
Yes, sir. So we can write this as 2y.
2 into 2 by 2 log of sine t dt, and this will become pi by 2. Agreed?
Yes, sir.
This is 2 times. So I will be putting this as 2 by 2 integral of 0 to pi by 2 log of sine t dt minus pi by 2 log 2. This is nothing but I.
Yes, sir.
So you will get I is equal to minus pi by 2
Minus
log
pi.
2. I hope this question was interesting. I found an interesting question. So this is 2 things we used. One you used is a plus b minus 2, and you used even function properties, right? Agreed or not?
Yes, sir.
So with that we come to the session today's end. So if you want to stay back for clarification regarding that thing, I'll tell you. I'll stop the recording and first, and then we can talk. Just wait for 1 minute. I'll stop recording.